Hi again. Well, maybe you're watching these videos back to back, okay? Because continuing on the theme of inspection. So the last one I did was fairly long, wasn't it, about natural logarithms? I want to do a separate video for this one because this is another standard set of results that you need to learn and memorize, okay? So I'm going to begin with, straight away, integral of sine squared x cos x, and I'll normally give the class a minute or two to try and figure it out. I suggest you pause the video. But please don't pause it for too long because unless you've actually seen it, you're unlikely to get it. Okay, so yeah. Well, welcome back. Well, was that right? Either you've seen it or you haven't. Okay, if you haven't seen it, then it might have taken a little while to get it. Okay. Well, what's our answer going to be? Can I just start off by writing down a guess? Okay, that you may have come up with. Okay, that is this. Sine cubed x. Okay. Now I'll ask a question. Why might someone have guessed that as the answer? Think about it. Okay. Hope you thought about it. Well, the reason is because when you differentiate, and notice there's a theme here. Okay. A lot of the time, what I'm asking you to do is check your answer by differentiating. That is a lot of the time the method of integration. Okay. You come up with what the form the answer must take, then you differentiate to check. Okay. If you differentiate sine cubed x, you're going to get 3 sine squared x cos x. Look at that. Look at that. That is where the sine squared x cos x has come from. Okay, it's by using the chain rule. Again, another reason why it's called the reverse chain rule. It's by using the chain rule on differentiating sine cubed x, because you decrease the power by 1 to get sine squared x, and then you differentiate the sine x to get cos x. Okay, so that's almost quickly gives us our answer straight away, doesn't it? We just need to multiply that answer by a third. So we multiply the question there by a third. So what that means is our answer is going to be 1/3 sine cubed x plus c. Okay, and there it is. All right, now before I go on to the next example, let me give you another one to have a go at. Okay, so I'm going to write it up. Integral of sine, and in this case I'm going to ask usually someone to come up with a power for me. Good, 7. Chances are some of you chose the number 7. Okay, sine to the power 7x cos x dx. Right, pause the video, have a go at it. Right, hopefully the video has been unpaused now, and hopefully you reckoned that the answer is going to be something to do with sine to the power of 8x. Okay, something to do with that. Why? Well, because when you differentiate sine to the 8x, you are going to get d by dx is 8 sine to the 7x cos x, and that very nearly gives us our answer, doesn't it? Okay, so hopefully that will tell you that you need to multiply sine to the x by 1/8. Okay, that is it. Okay, try and see if you can come up with a general rule now. A general rule for this. Integral of sine to the power of n x. Now, okay, I'm going to say that n is an integer. Quite often they are positive integers. Okay, they're hardly ever fractions in these. Okay, the most common ones that come up are the ones that I've just given you. Okay, but yeah, in our simple example, just imagine that it is just a positive integer. Okay, but n can actually be any reasonable number in there. All right, sine to the nx cos x. Come up with a general rule for that. Pause the video again. Okay, unpause, and hopefully you get the idea that you're just going to increase the power by 1. So that's going to be sine to the n plus 1 x, and you could divide by n plus 1, and then plus c. That is it. Okay, a rather handy rule for you to know. Okay, what you would find really difficult is if I give you something like this. No, not one of those. Just delete that. If I gave you one of these, sine, let's just say to the power of 5x dx. Why is that slightly harder? Just have a think about it. And you're absolutely correct. Okay, or you're absolutely wrong. Maybe I've read your mind wrong. Okay, well, you're either correct or you're wrong, aren't you? Or you just didn't even think about it. Your mind was blank. But hey, I would rather your mind wouldn't be blank. Okay, as yeah, I'd rather you try and think these things through as well, as if you were in the classroom with me. I don't just simply listen and take things in, because if you do that, you know, you don't really learn, do you? You know, if you just sit there and watch a video, okay, you're not really taking it all in. I'd rather you try and make it as interactive as possible. Try and have a go at it, okay. Well, the thing is, because you don't have an additional cosx there, okay, you need to have that cosine x term in order for this rule to work, okay, and that is it. What you're looking for is you've got the integral of some multiple power of sine x, but then only a single cos x term, that is power of 1. Okay, so some multiple power of sine x multiplied by cos x, and the reason is when you differentiate using the chain rule, you are going to get some multiple power of sine x multiplied by a single power of cos x. Okay, so if you're interested in this one, well, you need to use a series of identities, okay, or you need to use what's called a reduction formula. Okay, some of the further mathematicians might be able to help you with that, or you can look it up on the internet. I'm sure someone somewhere has done a YouTube video on that. Okay, but maybe they're not as entertaining as me. So let's move on. Right, next, have a go at this one. Pause the video. Welcome back. If you've not managed to pause it, quick, get the pause button before I start going over the answer. Missed it, too late. Okay, I'm going over it now. Right, so hopefully you got the idea that it's going to be something to do with cos to the power of 6x. Okay, something to do with that. Why? Because when you write down y equals cosine to the 6x, you differentiate, you get dy dx equals, and then you get 6 cos to the power of 5x, and then multiplied by negative sine x. And if you compare that with our question, the cos to the 5x sine x looks good, doesn't it? Looks good. You just got to multiply your answer by negative 1/6 and put in plus c. Okay, so see how that works? Exactly the same as before, except all I've done is chosen a multiple power of cosine x this time. Okay, right, try and come up with a generalization for this. So integral of cos to the n x sine x dx. Pause the video until you got it. Okay, if you got it, right, so good. So that is going to be cosine to the n plus 1x, and then it's going to be negative 1 over n plus 1, and then plus c. That is it. And that is a really handy result to write down as well. Okay, so here you're looking for any multiple power of cosine x and a single power of sine x. Okay, so that couple of results are really important as well, because they are inspection. So if you just go back to the original questions here, so all we're doing is just using that rule and writing down the answer. Okay, yeah, I've written down some explanation stuff there, but in the examination you don't need to explain yourself to the exam, you just write down the answer, don't you? Okay, so you need to be able to write down those as well. Right, I'll see you again.